Hello students, so this video is for 7th standard subject science and chapter number 15, that is your light and associated phenomena. So let's start this chapter. So on starting this chapter we have already studied in the previous classes about the properties of light, and the basic property was the first property, and the one and only the property that we studied in the last year was your rectilinear propagation of light. So we have seen light travels in the form of beam of rays, you can say, and they always travel in a straight line. So this property of light, that is in which it travels in a straight line, is called as rectilinear propagation, which simply means moving in a straight line. And this property is responsible for the characteristic of shadow formation, or you can say the shadow formation that occurs is cause of the rectilinear propagation of the light. And in nature, if you have to see the concept of eclipse, whether it might be your solar eclipse or your lunar eclipse, they are all based on the principle of shadow formation, and indirectly we can say they are formed cause of the rectilinear propagation of light. Then moving on, the next topic that we have is your reflection of light. So we know about the concept of reflection, that basically means bouncing back from any surface. So even when we'll go to higher classes, we'll study about the particle nature and we'll study about the wave nature. So we can say that light also get reflected from a surface once they hit the surface. So this bouncing back of light from a particular surface is called as the reflection of light. So now moving on, reflection can be categorized as of two types. First one that we have is your regular, or you can say your specular reflection. So in this diagram, that is for figure number 15.1, you can see when the light is traveling in the form of beam, that is a large number of parallel rays are traveling. After hitting a particular surface, they all will be reflected in such a way that all the reflected rays, you can say, they will be parallel to each other. And this type of reflection occurs when the surface is very smooth, or you can say very shiny. And then the second type that we have is your irregular or your diffuse reflection. And this type of reflection occurs from the surfaces which are not smooth, or you can say from the rough surfaces. So in this, what happens basically with the specific direction of the arrows, you can see. So after, when they are when they are going in for the incident, that is, they are going to hit the surface, they are traveling in a form of parallel lines. But once they get reflected, right, they travel in some random directions. That is, the reflected rays are not parallel to each other. So the main point to be remembering is regular reflection occurs from smooth surfaces and irregular reflection occurs from rough surfaces. Then we have the concept of plane mirror. So plane mirror is nothing but a flat surface that you have seen in your you'd have seen in your house also, right? Now, like when you are using for when we are like getting ready for school and looking at ourselves, or when we are doing brush and all in washroom and all. So that time you have seen the plane mirrors. So what happens, like normally we would have seen that the mirrors are basically made up of glass, but the glass that you would have seen, like for example in your windows and all, but that time the glass is considered as a transparent object. So how come the mirror that is again made up of glass is acting as a reflecting surface? So you would have seen a specific type of coating. So normally we use lead oxide coating on the back of you can say on the back of on the back of your glass actually. And then we also use silver foil, that is basically silver is basically the best reflector. So the reason is that only. Now the peculiar characteristics that you have to remember for the concept of plane mirror is that the image formed is laterally inverted. So what does it mean basically? So, if you go in front and stand in front of a mirror, then you will see, if you are raising your right hand, right, then the image formed in the mirror will be having will look like as if the person who is standing in the mirror is raising its right hand, right, sorry, left hand, right. So, and if you are raising your left hand, then you will see the image that is formed, right. It will seem as if it is raising its right hand. So when the right becomes left and the left becomes right, so here what I mean to say, the right of object becomes left of the image and left of the object becomes right of the image, is called as lateral inversion. And the best example for this you would have seen in the book that is also given, the how the ambulance actually is written on the top of on the vans, right. So what happens is, like, when driving, right, when an ambulance is behind you, you can see in the rear view mirror the image formed will be in a correct way. So the best example is that only. Now there are certain other characteristics of also of a plane mirror, and those are something like they are always upright. You can say, like, if you're standing in front of mirror, your head will be on the top and your legs will be at the bottom, right? So it is always upright, or you can say erect image. Always virtual. The virtual basically means the images that cannot be captured on a screen right? And then the size of the object for the plane mirror, it always remains the same, right? And the one conceptual topic is basically they mean to say the distance, or you can say the object distance, is always equal to the image distance. Then again, moving on, we have an example, we have one more definition that is called as your real image. So real images are those images which can be captured on the screen, and the best example is like when you're going to a cinema hall. So the projectors are basically used. So that time they are putting up a particular images. Movie is nothing but a sequence of images. Those type of images are called as real images that can be captured on a screen. Now. Basically, if we go and further, then we'll be having certain definition, like here specifically they have shown the concept of how exactly the reflection is occurring. So if you look at the figure number 15.4, we have a plane mirror, and the first definition is your incident ray. So the ray which is falling, right, it doesn't occur that as if a light is traveling in the form of a single ray, but for our understanding purpose we are just taking one simple ray only. So the ray which is going towards the mirror, it is called as the incident ray, and after reflection the right ray is called as reflected ray. So at what is the point of incidence? Basically the point where the incident ray and the reflected ray meet, right? Or you can say the point where the incident ray approaches and from where the reflected ray starts, that point is called as point of incidence. In your book it is given in the figure as point Q. Now the normal is just an imaginary concept. You can say from any flat surface, any line which is emerging perpendicular to the surface is called as normal ray. And then angle of incidence is again simple. The angle between the incident ray and the normal ray, they are the angle lying between those rays. These two rays are called as your angle of reflection. And in the Distt diagram, it is given in the form of orange color. And the angle which is formed between the reflected ray and the normal ray is called as the angle of reflection. In the diagram, you can see it is shown with the yellowish color. Now there are two laws of reflection, and in the higher classes we'll be studying them in much more detail. So these laws are followed irrespective of the type of reflection, whether it might be a regular reflection or your irregular reflection. These laws are always followed. So what does they say actually? The first law is like the incident, the reflected, and the normal ray at the point of incidence, they all lie in the same plane, right? Then the second one is that at irrespective of the type of reflection, the angle of incidence is always equal to angle of reflection. So as far as we have seen, we have studied the concept of reflection, we have seen the concept of reflection, and for the plane mirrors we have discussed. Now coming to spherical, or you can say the curved mirrors. So you would have seen, gone to some places, if you are going to some sort of fair and all, ajab gajab ghat, like we call them. So there if you enter, then you can see weird shapes coming, like when you are standing in front of mirror weird type of shapes are being appeared. So there you can see spherical mirrors are there. So it is not like we in our day-to-day life we are only having plane mirrors. We also have spherical, or you can say curved mirrors, right? So what happens actually is, like, you can consider a hollow ball which is made up of glass, and we have cut two portions. Here you can see. So mirrors, on the basis of their curve, they can be either concave mirror or they can be a convex mirror. So in this diagram you can see red color lining. There is nothing but the part of the glass that we have taken, and the dashed line here are representing the coating of silver and your lead oxide. So when the reflection is occurring on the inside, right, the reflecting surface, you can say basically reflecting surface is towards inside, that time we say that the mirror is concave, and when the reflecting surface it is outwards, that time we say that the mirror is your convex mirror. Now there are certain definitions that you can see, right? The pole is nothing but the geometrical center. Geometric center basically means, like, if you take any shape, like if you're taking square or you can say circle. For example, for circle, I can say the geometric center will be the center of circle. And for example, if I'm taking the center of square, then I can say the point where the two diagonals actually meet, right? So the next definition that we have is your center of curvature. So we have, in the beginning, we have considered one hollow spherical ball. The center of that ball will be your center of curvature. Then principal axis is nothing but the line which passes through the center of curvature, and the pole is your principal axis. The next definition we have is your radius of curvature. So if you are considering C as the center and the any line, or you can say the radius of curvature is nothing but, you can say, mean to say the radius of the sphere that you have taken initially, right? Then principal focus is the definition that you have to understand, right? So we have seen two types of mirror. One first is your concave and the other one is your convex mirror. So what happens in concave mirror is like the concave mirror is also called as your converging mirror. So in the diagram you can see when the rays of light, a parallel beam of light is falling onto the concave mirror, after reflecting they all are converging at a point, right? So this mirror is also called this point, or the place where exactly all the rays after converging are meeting, is called as your focus. And in concave mirror, the focus is basically your real focus. So right now, next one, you can see your diagram is that is figure number 15.7 is your convex mirror. So what happens actually when a ray of light, or you can say parallel beam of light, they are falling on a convex mirror, so they diverges. But what happens, like if a person who is standing far away, for him it will look like as if they are coming from a singular point. So here in this diagram you can see some dash lines, dotted lines, they all are coming, and they seems to as if they are meeting at a point. So here the focus is basically virtual focus, and that's why cause the rays are after reflecting they are diverging in different directions. We also call it as a diverging mirror. Now, use of curved mirrors. So as far as concave mirror is concerned, it is basically used in dentist. Like if you go to dentist and all, they'll be having a spoon-like structure. At the end of it, you have a spherical mirror that is basically a concave mirror. Then we have shaving mirror. Basically it is used, and if you are looking at the headlights of your vehicles and all, there you can see. And then reflectors basically in some malls and all. So they're also they are being used, right? Now we have convex mirror. So the different examples had been given, but for a general point of view, if I have to discuss, I'll tell you. If you have to get a magnified image, then we go for the concave mirror. And if you have to go for like when the object is very large and you have to get a very small image of that, like for example when you are driving, in your rear view mirror you get a small picture of the car which is behind you. So that time we have the convex mirror concept, right? Now the first one property we have seen, that is a reflection. There is one more property that light also shows, that is called as refraction. So refraction is something like when the light goes from one medium to another medium, then the bending of light occurs, that the light gets deviated from its normal path, and this property of light is called as refraction, right? So this bending, or you can say the deviation that occurs in the path of the light when it travels from one medium to another medium, is called as refraction. So what you can understand, what could be the reason for this bending, or you can say the deviation, is that for example, if you are being asked to walk on road, you can walk easily, but if you are asked to walk in a muddy place, then there will be some slight change in your velocity, right? Even though you are applying some same sort of muscular force. So what is like your speed depends on the medium. So the light speed basically in air and vacuum is 3 lakh kilometer per second, but when it travels, like for example in water, it is around 2 lakh kilometer, and in glass it reduces further. So this change in speed basically of light is the cause of refraction. And as far as refraction is concerned, we have to follow certain principles, like whenever the light travels from a rarer medium to the denser medium, it bends towards the normal, and whenever it goes from the denser medium to the rare medium, it always goes away from the normal, right? And then we have the concept of lenses. So when we were dealing with the reflection, that time we had the concept of mirrors, and when we are dealing with the concept of refraction, that time we have to focus on lenses. So basically lenses are nothing, you have all would have seen, like the people who are wearing specs. So I'm not pinpointing, I'm just letting you know. So those again are basically lens, right? So lens is basically, you can say, is a transparent medium which can have both, which can have one flat or one curve, or you can say both the surfaces will be curved. And they have given you the examples of convex lens and your concave lens, right? So naming might be confusing bit for you, because we had this concave mirror and convex mirror, and we are having convex lens and the again concave lens, right? So when both the surfaces are curved and the bulge is outwards, that time we can say the lens is your basically convex lens. And when they are having sort of groove, or you can say depression on both the sides in the form of curved surfaces, that time the lens is your concave lens, right? So what you have to remember, like when the light travels, this time reflection won't be there. Light travels through a convex lens, so all the rays actually converges at a point, right? So that time the focus is basically your real focus. And the focal length, one more definition comes, basically there is nothing but, you can say, the distance between the pole and the focus, right? And concave lens are the lens, basically again they act as a diverging lens actually. And here again they will seem as if the points the light is coming from they seem actually, the word that you have to focus on is basically your seam, right? So light seems to come from a singular point, that is again called as focus, right? Principal axis is nothing basically the line joining the two center of curvatures, because here two curved surfaces are there. So what will happen, we have two center of curvatures actually. So the line which is joining the two center of curvatures is called as the principal axis. Here we don't have the concept of, actually I had used the word pole, but optic center is taken as the center of lens actually. Then principal focus is nothing where light rays converges after passing through the lens actually. Focal length is nothing but the distance between, you can say, your optic center and the focal length. Now image formed in a lens is a topic that we will be dealing in the higher classes. And now we have the topic that is called as your image formation in the eye. So one thing that you have to remember is, like, our eyes basically have lens, and that lens is in the shape of convex lens actually, right? And what happens when the light passes through those lens, when actually real and inverted image is formed on the retina, which basically is called as a screen for human eye. And from there the signals are being sent to your brain through the optic nerve, so that you can visualize what type of image and what you are seeing, right? So one thing, the words or the keywords for this is, like, our eyes have a convex lens, retina is a screen, object formed is your real and real, and you can say optic nerve is a nerve which is connected from your eye to your brain, sends the signals, or you can say the messages regarding the image formation. Now the last topic for this chapter is your splitting of white light. So what happens is, like, Sir Isaac Newton, a famous renowned scientist, he did an experiment. He told, like, if we have a prism like structure, and he said, like, when a white beam of light passes through a prism, after there will be refraction actually, there will not be reflection. So there will be two times refraction will occur, and the final ray of light which would be coming, it will consist of 7 colors, you can see, right? So here what actually he was trying to say or convey was, like, the pure white light is nothing but a mixture of 7 different colors. So violet, indigo, blue, green, yellow, orange, red, actually, that he tried to say. And for this he did performed a very small and fantastic experiment that was called as your Newton's disc, that we'll be discussing in the activities. So that's it from this chapter, guys. Take care, and we'll continue with the next chapter in the upcoming videos.